All right, today we're tackling the humble transformer. It literally makes our entire electrical world possible.
You see them everywhere, right? But here's the puzzle. Why are they rated in VA, not the watts we all know?
So, power stations are usually miles away, and that distance, it creates a huge problem: losing energy. Imagine sending power at the same voltage your house uses. The current would have to be crazy high. Over a long distance, you lose a staggering 87% of the energy, just gone as heat. So what's the fix? You use a transformer to jack up the voltage, which drops the current way down. And boom, the energy loss drops to less than 1%. That's why transformers are a total game changer. So how do they actually do this? The magic is a principle called electromagnetic induction. Now, here's the trick. This only works with AC. You need that constantly changing magnetic field. The transformer's real secret is the turns ratio, just the number of wire wraps on each side.
Okay, so this simple equation tells you everything. More turns on the secondary side means higher voltage. Easy.
But what's really cool is current does the exact opposite, thanks to something called ampere turns balance.
See, this ampere turns balance is how power is conserved. Basically, power in equals power out. Nothing's free.
So check this out. Voltage drops by 10 times, so current has to go up by 10 times. A perfect trade-off.
Okay, which brings us all the way back to our original mystery. Why volt amps and not watts? The answer is something called power factor. And to get it, just think of a glass of beer. The transformer has to supply the whole glass. That total is called apparent power, measured in VA. True power is the actual beer, the useful stuff. Reactive power, that's just the foam. It takes up space. So the manufacturer rates the transformer for the whole glass because they don't know your beer to foam ratio.
Okay, but let's get real. Transformers aren't perfect. They lose some energy and make that classic hum.
You've got copper losses from heat in the wires and iron losses from currents in the core itself. And that hum you hear, that's the metal core literally shaking back and forth 60 times a second. So to wrap up, they boost voltage to cut current and energy loss. It's a simple, powerful trade-off. It's just amazing. This simple 19th century device, run by a few clean equations, powers everything. So it makes you wonder, what's the next great leap? What principle of physics will power our future?